Well, thank you, Kees, for this wonderful introduction, and welcome all. Well, as Kees mentioned, my name is Marjolein, and today I'm here to hopefully inspire you a bit about all the integration possibilities of the Thinkwise platform. So, as you've all may have seen in this morning's keynote session by Peter Paul, we are moving away from that typical enterprise landscape with all these apps on the sides, and we are moving towards a more agile situation with the Thinkwise platform, and a lot more clean and simple. But although we are moving toward this more simple landscape, no software can contain everything, especially for example, you would not want to recreate Microsoft Word or create your own messaging service. And even maybe you don't want to create an entire very specific payroll application within your own core system. So what you actually want to do is combine this all and get the best of breed of both. So to integrate, if you integrate, you will reduce the amount of side apps that you have to create, but you can have the best of both worlds. So for this presentation and well, actually the rest of today, I think the word integration is key here. And well, I'll hopefully show you today how we can achieve this with the Thinkwise platform. So, well, let's start with our situation in the world currently. You may all notice we live in a world of rapid growing technology, and the amount of data that's in the world is even ever growing higher and higher. And the world is growing even more and more connected. Well, if you go on a bike ride, for example, well, if you didn't log it into Strava, it didn't happen, right? Or you cannot walk into an electronics store and find a TV which is not smart. So these data-generating devices are all around us. And if you look at this graph over here, you can see all the IoT devices that are connected in the world. Well, this is a forecast, actually. So now we're here around the year 2022. And you can see that this is a very rapid growth of connected IoT devices. Furthermore, if you look at all the data which is generated in the world, only for the year 2022 until now, we've already generated about 100 zettabytes of data, which is actually, well, around, I guess, 1 billion terabytes of data. So that's a huge amount. And approximately 70% of all this data comes from those IoT devices. So let's make a bridge to our core systems then. Because if you look at this graph, you can see that the yellow part over here, these are all enterprise IoT devices, such as machine sensors or traffic signs, and all such things that contribute to the information that our business requires. So even without this rapidly growing amount of data, core applications or ERP systems, or however you want to call them, they are complex by themselves. They are huge, they cover the whole business, a lot of stakeholders are involved. So these projects take a lot of time and they cost a lot of money. So business managers or other stakeholders are highly involved in the quality of such an implementation process. And even if you use, if you create a great core system, and I think it's essential for modern-day businesses to have a well-functioning core system. You can create competitive advantage. And in the current situation, with all these data that's generating all over the world from all those devices, or maybe from social media even, you cannot deal with it by just leaving it there. This information is there, and you have to use it, and you have to integrate this in your business processes. So, what does this mean for our business? Implementing these integrations and connecting to all those IoT devices, it's essentially a part of our business, right? So, as I've underlined the importance of this, today I would like to illustrate this to you by using a business case. And maybe the image over here already tells us a little bit what this business case is about. But this business case for today, we've created a technical maintenance company. And this technical maintenance company is responsible for the maintenance of air conditioning units. And they have several customers all over the world. But one of their branches they operate in, it's the hospital branch. And for one specific customer, a hospital here in the Netherlands, they have a service level agreement to maintain their air conditioning units. And well, normally such a service level agreement of an air conditioning maintenance company would not have very high priority, but you can imagine that in a hospital with operating rooms, laboratories, that is very important that the air quality is consistent. So for these hospitals, the maintenance company has a high-level service agreement, a high priority service level agreement, which means that they have a time to arrive of 1 hour. So if something goes wrong, a technician or a mechanic has to be there in 1 hour. So if we look at the current process of this organization, you will see that there are a lot of process steps. Well, in the first place, something happens. An air conditioning unit is overheated, so it will break down. And after that, somebody in the hospital will notice that and say, hey, the temperature is rising in a room, or the machine is giving an error. And the facility employee of the hospital will call the service desk. Well, the service desk will call to the service desk of the maintenance company, so that's our second phone call. And after that, this employee over here will check the service level agreement, check which device is giving the error, and what information there's else important about the situation. So after that, based on the urgency of the call, well, in this case, it's overheated, it's broken down, so you might guess that we take the upper path. But else, they would plan a scheduled maintenance manually. And if it's urgent, it will check, the person will check the availability of mechanics, and these mechanics will be informed. He will get the information about the device. He will check on Google Maps how to drive to the location, and then he arrives at the location to fix the air conditioning unit. Well, if we look at this process, we can see that there's a lot of reactive maintenance here, because we start fixing the problem if the unit is already overheated. So that sounds a bit like a problem. Secondly, this process is also quite sensitive to errors, because the people that are making these phone calls over here, well, they can make a mistake, or they can misinterpret the message from the device. And last of all, this process has a pretty high turnaround time. So our case company decided they want to improve this process, because it's creating waste. And first of all, we want to reduce all this human interaction because that makes it take longer, and it creates a lot of error sensitivity. But also, we want to reduce the amount of steps that the process goes through. Finally, and maybe the best of all, is that we want to switch towards a more reactive, proactive maintenance. So instead of waiting for the device to break down, we want a warning that the device is starting to heat up. So hereby, we reduce human interaction, improve the process, and we act before the error occurs. So if we would automate this process, it would look a little bit different. And as you can see here, this is our new process, and I will show you later how that we've done that. If the unit starts overheating, or air conditioning device or IoT device will send a message, system will check that message, find the correct service level agreement. This check will also be automated, and if it's a scheduled maintenance, the system will automatically plan this, or else the system will check the availability of the mechanics, check who's closest by, and sends all the information to the mechanic so he can drive to the location and fix the air conditioning unit. Furthermore, even if you not just look at optimizing this process, another thing that is nicely you get for free is that this approach is more data-driven. Because now you will start your maintenance if something starts to happen, and you will analyze this data. This IoT machine generates data, and maybe you can even in the future predict when maintenance is required. So this helps us to switch to a smarter way of scheduling our maintenance, which will add value in the end. So now let's have a look at how this would, how it looks like within the Thinkwise platform. And you may have seen this slide before. I'm not going to explain the entire slide, but for now it is important to remember that our landscape is a three-tier system. And the first, the tier here on the left is the backend. This includes the product database, the software factory, the authentication layer, IAM. And on the right, we have the user interface, or the interface layer. And in the middle is our application tier, or API. And that's where we will focus today, because this is the place where our process, or business process, will be handled. So if you look at the current situation, which of the new situation, which I described in the slide before, you can see that we need a process flow to achieve what we want. And this process flow will be controlled by our API, and as a start, it will receive the information from the air conditioning device, and we set up Amazon's simple notification service to make a call to our API. This triggers the start of the process flow, and during the process flow, we will be connecting to Microsoft Graph for the authentication of the Office of the Microsoft 365 environment. And we will also be connecting to Google Maps. So that's briefly the situation as it is in the Thinkwise architectural landscape. So let's zoom in to the start of that process. And as you can see here, this is our air conditioning unit. And if it will constantly give us data. For example, here you can see that this is the data that came from the air conditioning unit. Well, we actually faked this for now, and I'm even not sure if 107 degrees, maybe that's even normal. I don't know, I'm not a mechanic, but in my perspective, 107 degrees would mean we have a problem, because it's really starting overheating. But this air conditioning device doesn't contain any logic. The air conditioning device only will tell what is going on within the device. So to apply some logic to this, we used Amazon IoT, and within Amazon IoT, we've created some rules. And these rules tell us that if such a situation occurs, we will have the situation with an error message. So it will give the device ID, the temperature, and we said the max temperature is 110 degrees, and it will generate a message that the temperature is approaching a fail-safe level. So all of this information is transferred from Amazon IoT with Amazon Simple Notification Service to the Thinkwise application. So if this process is triggered, you can find here that we start with the process flow, and the first step of the process flow is a task. And this task, we've created this in the software factory, will interpret all these parameters from the JSON object you saw in the previous slide. So these parameters, it will interpret it, and it will make the right decision for the process flow, what should be done next. It will find the correct information. It will find the correct information in the database because we've created an application with a database which contains the customer information, all the information about the IoT device. It contains the service level agreement, and all of these information will be automatically checked in the process flow, and based on this information, the process flow will either go to the start scheduled maintenance task or go to the next step to find the next available mechanic. And as you can see here, this is the next step. We found the next available mechanic using an HTTP connector towards the Google Maps API. From Google Maps, we checked where our mechanics are, and we already calculated, Google Maps already calculated the route for our mechanic to drive to the hospital that he's required to fix something. And then the next step, so after we've decided that we want to inform our mechanic, we use a standard OAuth connector to receive a token from Microsoft Graph. And using Microsoft Graph, we can connect to both Microsoft Teams and to our Outlook agenda to send a message and create a calendar item. And as you see, there are two paths leading out of this node. The first one will send a Microsoft Teams message, so it will inform the mechanic, send the information about the route and the service level agreement. And the other one will insert an Outlook agenda item into the agenda of the mechanic. So that's a process flow. And well, these steps may look familiar to you. Not sure if you all already worked with the software factory, but this is a process flow. So we've modeled this whole business process with all these little nodes here in our process flow. And as a quick recap, here we register the incoming event. We found the customer service level agreement based on the information that came from the event. If it were not urgent, we would have scheduled a regular maintenance, and if it were urgent, we will find the nearest available mechanic, call the web service to retrieve the distance and the route, authenticate with Microsoft Graph and to send a Teams message and an email, and that's the whole process which you've seen earlier in the diagram. So, well, you might think that it's actually quite a simple process. It's here to illustrate what the possibilities are. But you can imagine that you can apply much more complicated business rules to such a process flow. For example, here this check, now it leads to 2 pathways, but it could lead to 10 different options based on a lot of information that is available within the system. So this looks like a nice story, and well, if it weren't for Thinkwise, we didn't create such an application. So I will show you a quick video of how we've built this actual working application and talk you through it. So as you can see here, this is our universal GUI, and we set it up to a tablet device. So this is where the mechanic will check whether there are any device messages or check any other information that is required for this process. And you can see here we set up a Teams account for the mechanics, and you can see it's empty now. They didn't receive a message for now. And also their Outlook calendar is still empty. Nothing's there. So now let's have a look at Amazon IoT. And here we've set up an MQTT test client. And in this client, we have created a topic. A topic is a situation where something happens. This topic has a name and a message payload that you've seen in the earlier sheets before. And if we publish this topic, it will use the Amazon Simple Notification Service to send a message to a process flow. So now that we've published this, we can check out, and here we find an urgent Teams message with all the information and an image of the Google Maps route. So this was directly triggered in a split second, and the service desk employee was not required at all to retrieve and give some information. And as you may notice, this is actually the Isla Hospital in Zwolle, but it's just to illustrate. So we are not creating anything for the Isla Hospital. And here you can also see that the empty Outlook agenda now has an item in there. And if we look back to our application here, we can find that there is one device message. It has a badge which says there's one. So if we open that, we can find all the information that we've retrieved from the device through the Amazon service. And we can even look up more information about the device and the location of the hospital. That's where it's in. So that is basically how simple it can be to optimize one process. But now we've used an air conditioning unit. But you can imagine we could have done this with any other IoT device. For example, with traffic sensors. Or maybe with greenhouse technology. As the image here, this also gives us a rich amount of data which can be interpreted and used to improve our business processes. Or maybe sensors in packaging machines within your production environment to optimize your operations. But not only can we use all sorts of IoT devices, but we're also able to do this on any hosting platform with and integrate with any external service. So for this example, we've hosted this on a Microsoft Azure environment, but we could also have hosted this on Amazon or Google, or even on-premise, as you prefer that maybe. We used the Amazon IoT, but we could also have used Azure Service Bus or Google Cloud IoT, for example. Or maybe we could have sent our message using WhatsApp or posted on Twitter, although I would not recommend a service company to post their error messages on Twitter. What should you take away from this? Well, the possibilities are endless. You can create all your innovative business process and connect at any situation you want, and you are free of technology. You can use anything that suits best. And the greatest thing of all, that you can all natively integrate this within the Thinkwise platform. And in the way we do that, we do not we create these integrations sustainable. So we prevent you from creating that abomination image of the first slide with all these apps in our landscape. And if you drive home today, or maybe if you talk to each other during lunch, maybe you should think about which data do I have in my organization, and how can I use the data which is already there to improve my business process, and what things are there already which I can integrate with. Or even maybe you can think about how you can generate more data. Either way, I think it's a must to do something with this increasing IoT trend. So I'm actually very curious about how you will use integration within the Thinkwise platform. And well, I invite you all to share your great innovative ideas with the Thinkwise community. You can post that online. Very curious what you all will came up with. So for today, I hope I've inspired you a bit about all the possibilities of the Thinkwise platform. We'll switch over to a Q&A session now. And for this, my colleague Vincent will join me. He's the lead developer for our application tier. And he will be able to answer all your difficult questions together with me. Thank you, Vincent.
Thank you, Marjolein.
So I believe there is somewhere of a microphone device here in... Ah, it's over there.
Yeah.
So who's got a question? Who dares? Over there. Okay, well, let's try this. Well, that actually went quite well.
Hello. Hello.
Yes, it's working. Yes.
Tom Munster from Achmea. I'm really curious what technologies beyond your platform. Which technology is the platform running on?
Running on, okay. So the application tier is running on ASP.NET Core 6 right now. Our GUI, the universal GUI that you saw earlier, is built with React. And as for database platforms, currently we support SQL Server, DB2, iSeries, and Oracle. And we're looking into perhaps supporting more database platforms in the future as well.
Okay. Thank you. Very nice.
Any other questions? Oh, one over here.
On the front.
The front row here, yes.
Hi there. My name is Jonas Graaf from CACI. I was wondering, all the components you used in the flow to connect to the all the different spots, are those default connectors? So you can. Yeah, I'm not a user of your platform yet. So.
Yes, so all of those components are default connectors within the Thinkwise platform, within the software factory. Some require some configuration. For instance, an OAuth connector to authenticate to Microsoft 365 requires some configuration. But for this, we offer standard configurations in our Think store, where people can download them and integrate them into their own solutions, their own projects.
And for example, there's this task node within a process flow that can be anything that you've programmed in SQL.
Yeah, exactly. Any more questions?
No.
Well, looks like that was it.
Yeah. Well, then I really want to. Oh, there's one more.
Oh, one in the back.
In the back. Well, we cannot see you at all over there. That's very difficult.
It's very dark. We'll get it there eventually.
It better be a good question then.
There we go.
Yes, thank you very much. I'm Marjolein from Amoda, and I've got a question. In your previous slides, you mentioned that it was platform independent, but all the services you used, they are always independent, right? Because you always are stuck with the Thinkwise platform, and that only runs on Windows. So what do you exactly mean by it's platform independent?
So the Thinkwise platform doesn't only run on Windows, it also runs on Linux and Mac, if you would like. It runs on every cloud platform, it runs in Docker containers. So the Thinkwise platform can run anywhere. It's fully cloud native, as you might say. And furthermore, we continuously adapt new technologies as they come out to take this away from this worry away from our customers. So currently we have an application tier that runs on ASP.NET Core 6. Previously we didn't have this, so this is something that we introduced over the years, and all our customers get this for free as an upgrade.
Okay, but the software factory is only Windows, right? So that's not platform independent.
So the software factory, which is the development environment, the IDE, you might say, it does run cross-platform, but there's a couple of components that are still Windows only right now, which we're working on to migrate them to our universal GUI. Because our universal GUI is a web-based GUI, which runs in the browser, so it runs everywhere. The application tier also runs everywhere, so we're currently in the process of migrating these last few points to the universal GUI.
Okay, thanks.
But production environments are already fully platform independent. Can we get a mic over there? So this is going to be a challenge.
Oh, nice.
Nice.
Does it work? Oh, yeah.
Yeah, very loud.
So I have a question about your demo. You built this really nice application. How much actual development time was in it? Because we can build this in other solutions as well, but I think that one of the core selling points would be that this would be very easy and quick to build with your solution.
Yeah, so in this case, a couple of people worked on it on and off over a period of time, but I would say that something like this you could make in a day if you would want to.
Okay, yeah. In a real situation, it'd probably be more complex, but that gives a really good indication of
yeah, exactly. So this specific business process, to automate it, you could do it within a day, let's say a couple of days, a few days.
Okay,
yeah.
Thank you. I can't promise I can reach anybody else as well. But
Are there any more questions? I think that was it.
Yeah. Well, if anything pops into your head, we'll be around for today, so feel free to address us at the stand, or maybe we'll see each other next time.
Yeah,
So thank you very much for your attention.
Thank you, everyone.